PTFE stands for polytetrafluoroethylene, which is a type of synthetic polymer called a fluoropolymer. A fluoropolymer is a type of polymer that consists of carbon and fluorine molecules, and the main constituent of polytetrafluoroethylene is tetrafluoroethylene, TFE, which is a member of the fluorocarbon family. The most notable attribute of PTFE is that, due to its low dielectric constant, it is entirely hydrophobic, which means that water cannot pass through this synthetic material. This attribute has made PTFE highly popular in any application where the blockage of water is desired on a large or small scale. In 1938, Roy Plunkett, a young scientist at DuPont, accidentally discovered PTFE when trying to create a new chlorofluorocarbon refrigerant. Plunkett hoped to create the new refrigerant by reacting hydrochloric acid with tetrafluoroethylene, TFE. He stored the TFE gas in metal cans and during his tests used the weight of the cans to measure of the amount of TFE used in each experiment. On April 6, 1938, Plunkett discovered that although the weight of the gas pressure bottle didn't signal that it was empty, no gas flowed out of it. Out of curiosity, he decided to examine the source of the weight and eventually resorted to sawing the metal can apart. What he found was a white and flaky powder on the interior of the pressure bottle. The TFE had polymerized overnight with the iron from the inside of the can acting as a catalyst. This new polymer was later registered as Teflon. PTFE is polymerized from tetrafluoroethylene, TFE. In turn, TFE is created by combining fluorspar, hydrofluoric acid, and chloroform. To create TFE, these three components are combined under high temperatures through a process called pyrolysis. The resulting substance is in a gaseous form and it is converted into a liquid under high pressure and low temperatures. TFE is highly volatile, so it isn't commonly transported. Instead, most PTFE manufacturers make their own TFE on site. In the process of creating TFE, small amounts of a number of different chemicals, such as disuccinic acid and ammonium persulfate, may be used as initiators, and large amounts of water are also used in the PTFE production process. Once TFE has been acquired, PTFE may be made in a variety of different ways, and most manufacturers of this type of fabric have production process trade secrets that they do not share. However, the various production processes used to make PTFE can all be sorted into two basic categories: suspension polymerization and dispersion polymerization. In addition, PTFE has an incredibly high melting point. According to Chemours, PTFE can resist temperatures of up to 600 degrees Kelvin, which is the equivalent of 327 degrees Celsius or 620 degrees Fahrenheit. Polytetrafluoroethylene also has one of the lowest friction coefficients of any polymer, which means that it is slippery to the touch and easy to clean. Furthermore, PTFE has high abrasion resistance, and it has high tensile strength. PTFE is used in a wide variety of applications. Nearly 50% of the world's PTFE is used in the computer industry since it has high dielectric strength. Since its initial use in the Apollo missions, NASA has used PTFE in many different manned and unmanned space missions. And this substance is also used to make insulation for wires in extreme climates like Antarctica. Since it has a low coefficient of friction, PTFE is also used in bearings, bushing, gears, seals, and gaskets, and it is commonly used in the production of carbon fiber composites in the aerospace industry. The UV resistance of PTFE makes it popular in outdoor industrial applications, and PTFE is also commonly used to coat the outsides of flexible architectural materials. China is the largest producer of PTFE. In 2016, this Asian nation exported PTFE material worth $154 million, and the USA is China's main competitor since it produced $118 million of PTFE in the same year. After the USA and China, Germany, the Netherlands, Italy, and Japan are the next biggest exporters of PTFE.